Okay, hey guys, I said I'd make a little video explaining some of the content from today's practice task and yesterday's practice task that you were looking at home. The main purpose is that you get an idea for the way that the question will be formatted. So it'll be one big problem with a few things to calculate. In this practice task, solar sail, I've given you the measurements here, but when we do the real thing, we'll take our own measurements like we were doing out by the bank by the maths block the other day, and also when we were looking at how high the linkway was off the ground. So we've practiced that skill separately. So this task here is about a solar sail made of fabric. That's a shade basically. You're told in the instructions here that it's fixed in tension at its corners. So that means that that's where it's held down to the ground and to the top of a pole. And a manufacturer is employing your services to supply sketches showing the dimensions so that they can make sure that the solar sail delivered fits what we need to put up. Say we were wanting to make a shaded area around the school grounds so that students could sit under it at lunchtime. This activity requires you to take measurements. I said that I've given those for you, but in the real thing we will take measurements. And you'll do that in groups, just like in this task. Working in a group, you are to take measurements of your site. Then working independently, you are to perform appropriate calculations and complete a sketch. So that's the basic introduction of the task. And then we come down to the task itself. Okay, so we're told, it says your teacher will indicate a position of your particular solar sail. As I said, we're not doing that because I've given it to you, but this here is a diagram of kind of what is going on. The points A, C and E represent the corners of the solar sail. So A, C, E, trace your pen over those corners to help identify them. And then using the points and or measurements that you're given by your teacher, calculate the height of point A. This will determine the length of the pole. So find that on the diagram. There's point A. Okay, that's the pole. Then find all dimensions to determine the size and shape of the solar sail, which is this triangular piece of fabric. Write a description of the shape of the solar sail using the dimensions that you have found. So normally in a assessment task, there will be bullet pointed things that you need to do. That's a good indication of little steps that you should tick off one at a time if they are there. Then we're told about the manufacturer will deliver the sail to your location with the pole, and that the pole is going to be placed at an angle of 13 degrees to the floor of the delivery van. The pole will be 2.5 meters longer than the height that we calculate here, and that is because it needs to be sunk into the concrete foundation and still leave room for fittings and to make it all nice and secure. One end of the pole will be at the left hand lower corner of the van and the other end will be at the right hand upper corner of the van. And we're told that the width of the van is 2.4 meters, but actually we can get any other size van that we want. It says calculate for the manufacturer the height and length of the smallest van that they can use to deliver the solar sail with its pole. So you'll need to do that too. That is extra. So we're going to start back up here with the information we're given about the solar sail and see if we can find what we need. First of all, we've got these measurements. It says BC here is 8 meters. There's B to C, so I write that on my diagram, 8 meters. B to D, here to here, is 2 meters. And I'm told that the angle ACB is 23 degrees, or I will have measured that using a clinometer. A to C to B, that means it's this angle in here is 23 degrees. So those measurements I've been given. Okay. The next thing to think about is where some right-angled triangles are, because this assessment is all about using right-angled triangles. Here, the pole across the base and where the edge of the solar sail goes is a right-angled triangle. Okay. Might be helpful if we write on here that this is the pole, so that we remember that and acknowledge that. Something else that might be useful at this stage is to just identify what the solar sail is, or the shade is. It's this triangle here. It's attached to the ground, and it is along that same line AC where that imaginary triangle is, whereas our shade sail is actually a piece of fabric. Okay, and you may be able to determine if this is directly in line here, that and that AC and then CE are perpendicular. There's a right angle there on the shade sail. So immediately before I'm calculating anything, I'm practicing finding right angled triangles. I've got two triangles in here. I've got my immediate one with the pole on it. There's my blue triangle. Okay. It's 8 meters along the bottom. It's got a 23-degree angle in there. And here's my pole. It goes from A to C to B. The other triangle that I've got is my orange shade sail. I'm just going to draw that down here. I don't have many measurements on this orange shade sail. I know that that's a right angle. This is the point A, down to C, across to E. Okay. What I do have on there is that this 2 meters is the same as that 2 meters. So I know that this CE side is 2 meters. I know that this AC side here is the same as this AC side there. They're the two bits that are touching on those triangles. So I know that whatever I find, we'll go up here, whatever I find this to be will also be the same on that triangle there. So that could be quite helpful information. I also know that this here is my pole from the original diagram. So I now go back to the information and I see that my first point was calculate the height of point A. This will determine the length of the pole. Well, that is this here, that side. We could call it X if we want. That's what we want to calculate first. Or we could call it the side AB. I might use X to start with, then I'll change to use different things. So the height of my pole I'm going to calculate is the X value that I'm going to calculate. Once I've done that, I can move in to find the dimensions of the shade sail, which is my orange triangle. So I'm going to just move this out of the way a bit, and I'm going to copy down my blue triangle here, okay, so that I've got it to work with. Oh, ignore that little bit there. So I've got 8 meters, I've got 23 degrees, I've got A, C, and B there. And I want to find the height of the pole. That's what I had up that side. That will tell me the height of the pole that I need. Here I've got a right angled triangle. I'm using an angle and a side to find another side. So I'm using trigonometry because an angle is involved. Label my triangle. Opposite the angle is O. The hypotenuse is opposite the right angle, and the adjacent is the third side adjacent to the angle. There's nothing on the hypotenuse side that I'm using at the moment, so I'm just going to ignore it, which means I'm using O and A, which is TOA, which stands for tan of the angle equals O over A. And so we have tan of 23 degrees equals O. X is on my O side, over A, which is 8. If X is on the top of the fraction and it's being divided by a number, to solve the problem we need to times by that denominator. So our last bit of working is 8 times tan 23 will tell us what X equals, and then we put that into our calculator, which I have here. 8 times tan 23 equals, and we can see here it's 3.3957 duddy. This would round to 3.40. That 5 tells me that the 9 needs to go up, so we can treat this almost like 39 and round it up to 40. So I've got now that x equals 3.40, and that's in meters. Okay, so I found the height of the pole. The height of the pole is 3.40 meters. That means that I've solved that part of the problem, and I'll clearly write the height of the pole needed is 3.40 or 3.4 meters above the ground, because I remember reading that it actually needs to go below the ground too. Okay, so that's the first bit of my problem solved. Go back to the original instructions, and we have here, cool, we've calculated the height of the pole, or where point A goes to. Now find all the dimensions to determine the size and shape of the solar cell. Well, that was the orange triangles that I was dealing with here. Okay, so I said once I had found the height of the pole, I might be able to go and use that for another part of the triangle, and that's the case here. I now know what that x is on this triangle. Okay, so if I pull my working back from just before, I can replace that pink x with what that value is. So I've now got 23 degrees, 8 meters, and I just found that this height here was 3.4 meters, or 3.40. A, B, C. I can call this side AC. I can look at the letters on either end and give it a name, AC. Okay. I can find AC on this triangle, and it's the same on the other triangle. I've got two options here. I can either use these two sides to find AC, side, 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 we're using Pythagoras, or I can ignore that and use this angle and this side to find that side, like I did up above. Okay, so two options, depends on how you see the problem. But if I'm using trigonometry like above, that's A, that's H, and I'm actually going to ignore that one that I just found. And then I'm using K, because I've got A and H. Cos of the angle equals A over H. Cos of 23 degrees equals 8 over AC. I've called it AC, you could call it Y if you wanted. Here is where we've got a number being divided by the term that we want to find. We can't solve our problem that way. We need to multiply by AC to get it out, and then we'll divide by cos 23. And this is the little shortcut that I showed you, that we could effectively swap these over, because we're multiplying by AC, then we're dividing by cos 23. AC equals 8 divided by cos 23, and when we put that into our calculator, 8 divided by cos 23 equals, we find that that side is 8.690. Okay, if we're keeping everything with one decimal place here, 8.7 is fine. I might keep 8.69 to start with, and then I can decide later on. So I've found out that the side AC equals 8.69 meters. Okay, so back on this original diagram now, here I've got AC 8.69, and that's the same as this AC, 8.69. So now I'm working with the orange triangle, and I can start making some calculations there. So I've got two sides of my orange triangle. Okay, I'm going to redraw it out so that it's a little bit bigger and I can see what's happening. So I've got A, C, E, that's 2 meters. I've just calculated that's 8.69 metres, and I want to know what this length is here so that I can tell the manufacturers how to cut it. I can call it the side AE, or I can give it another letter. That's absolutely fine. I'm dealing with side, 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 so I'm using Pythagoras. Pythagoras is a squared plus b squared equals c squared. I need to label my triangle. C goes opposite the hypotenuse, the right angle on the hypotenuse. A and B doesn't really matter, the other two sides, one of each. So in my triangle A is 2, so this is 2 squared plus 8.69 squared equals c squared. I put that in my calculator. 2 squared plus 8.69 squared equals 79.5161. Then I need to square root everything so that I get left with just c, not c squared. So I need to do the square root. Okay. If I've got it on my calculator screen already, it's quite easy to hit the square root button, and then I can just click answer, and that will put in the last answer from the calculator, or I can retype it in. That tells me that I've got C equals 8.92 metres, rounded to 2 decimal places. So I now know that this side here is 8.92 metres. And I can easily tell the manufacturer the 3 lengths of my right angled triangle that create this shade solar sail. If I want to, I can also go in and tell them what angles the corners need to be cut on. But because I know this is a right angle, the manufacturers shouldn't need that too much. As long as they get that angle right, then this should all line up quite nicely. Okay, so that is the first part of this problem. It goes through using trigonometry and Pythagoras, and you have a couple of options in some places to work on either of those skills. Okay, you need to choose the one that works best for you with however you see the problem. Then we go into the last bit of the question, which is about the delivery. Okay, the delivery of the pole. So we were told that the pole, we weren't told, sorry, we calculated that the pole's height is 3.4 metres. That's the height from B up to A there. Okay, so then we're told here in the information the pole will be 2.5 metres longer than the height that we've calculated up here. And that's because it needs to be sunk into the ground, so that there's still 3.4 metres above ground and there's 2.5 metres going below ground. So I now need to take that into account, that I found that it was 3.4 metres. I need to add 2.5 metres to know that my total pole length is 5.9 metres. Total pole height or length. Okay. Then I'm told that that pole needs to fit inside a van. You need to use your imagination here, and you need to think that a van, effectively, in very basic terms, is a cuboid. Okay, that is a very, very basic looking van. There'll be a couple of tyres there and a couple on the other side. Our pole for for our solar sail needs to go from the top corner at the back to the front bottom corner at the right. Okay, or the other way around, it's okay. I'll just do that a little bit thick so that you can see it. Okay, that's our pole that's holding up our solar sail. This length is going to be the same length as if we went from this top back corner to this front right corner. It's the longest length through the 3D box. It will allow us to fit the longest length of pole in without the van needing to be overly big. Okay, So that's that there. We need to create a right angle triangle out of this. There, and imagine that this is the shadow of the pole that holds the solar sail. This creates a right angle triangle, okay, in there. Now we were told that the van is 2.4 meters wide, okay. The maximum allowable width of the van is 2.4 meters, but that's all the information we were given about the van other than that. So here's the width of the van, 2.4 meters. Nothing else we know about the van. We know the length of the pole. The pole itself is 5.9 meters. That goes diagonally through the van's 3D space there. And we're also told in the information that the pole has to be placed at an angle of 13 degrees with the floor of the delivery van. Okay, so here is the angle with the floor. This is the shadow along the floor of the delivery van, and that's 13 degrees there. So using the shadow of diagonal lines through boxes to create right angle triangles is a good little technique. Okay, so we now have this triangle here. There's the pole, there's the back corner of the van, and there's the shadow it makes along the base of the van. We know that this is 5.9 meters, and we know that this is 13 degrees. And if we've got that, we might be able to find some of the other dimensions of the van that we need to tell our manufacturer to hire. So we've got the width of the van. This is the height of the van, which is the same as that measurement there, so that's the height. And this is the length of the van along there. Okay, we don't have that. This green line isn't the length of the van, that's the shadow of the pole which goes diagonally along the base of the van. But we can use what we've got here to calculate the height of the van quite easily. Okay, we're using trigonometry because we've got an angle and a side, and we're finding another side. Here's the opposite, here's the hypotenuse, and this is the adjacent. There's nothing on there, so we're not going to use it. We're using O and H, so we're using sine. Sine of the angle is O over H. Sine of 13 degrees is my little h, standing for height, over 5.9. This is like the first problem we looked at. We've got our variable on the top and a number on the bottom being divided, so we need to times by 5.9 to get rid of it. So we get 5.9 times sine 13 equals the height. That goes into our calculator. 5.9 times sine 13, 1.33. 1.33 meters. The height of the van is 1.33 meters. That's what we have calculated there. Okay, 1.33 meters for the height of the van. Now, we can find the length of the van. If you're getting all the way through this, you're definitely on track for high merits, if not better. Okay, and if you're showing lovely working. I can find the length of the van if I use a different right angled triangle from my original 3D diagram. This is the length, so I need that in my diagram. And I can use the width of the van, and I can use this diagonal from across there, and this, although it doesn't look like it, is a right angle triangle along the base. It looks like this. There's the length from there to there. I can use this side here is along the base there, so I know that's 2.4 meters. This is like a bird's eye view looking down on my floor of the van. I've just done that dash so you can see it's that dash line there. Okay, so this is now a right angled triangle that I may be able to use to find the length of the van. I don't have a lot of information here, which is a bit tricky. Okay, I'm probably going to have to go back to this original triangle and find A, because this, although I didn't draw it dashed, this here is my dashed base of the original triangle. So if I can find it there, it's the same one there. So I've got a bit of extra working, and this is why it's those higher level thinking skills. So I'm going to quickly calculate that. I'm going to find A using H, which is A and H is cos. Cos of the angle is A over H. Cos of 13 is, we'll just leave it as A, over 5.9. Just like before, it's being divided by 5.9, so to solve it I need to times by 5.9. And when I put that in the calculator, cos 13, I find that this is 5.75. 5.75 meters is that side A. So I now know this length, which is this length, which is here on this triangle, is 5.75 meters, the diagonal of the base of the van. And I can do my final step of working now and find the length of the van. Okay, I've got a side, and I'm finding another side. So that's Pythagoras. A squared plus B squared equals C squared. Label my triangle so I make sure I get everything in the right place. Opposite the hypotenuse is C. The other two sides are A and B. Up to you. I'm going to call my length A and my other side B. So then I substitute them in and I get 2.4 squared plus the length squared equals 5.75 squared. A bit different to the one we did earlier. Okay. I now have 2.4 squared being added to the length squared. So I need to deal with that. I need to get L on its own to solve this problem. So I need a minus 2.4 squared from both sides. That will make it disappear from there. And I need to do it from there. So I should get, I'm just going to move over here so I've got a bit of extra room, although I normally line up my equal signs. L squared equals 5.75 squared minus 2.4 squared. And I put that into my calculator. 5.75 squared minus 2.4 squared equals, I'm going to write that whole number down so that I don't lose any accuracy. L squared equals 27.3025. When I'm using Pythagoras, I need to square root at the end because I need to undo the squaring that's happened. 27.3025. And now I can square root and type in that number, or because it was the last answer on my screen, I can hit the answer button at the bottom of my calculator here. Just there, sorry. And then we get that the length of the van needs to be 5.23 meters long. This 5 tells me I need to round that 2 up. Okay, so I've worked all the way through and found quite a few bits of information. I've found that the length of the van is 5.23 meters. I found that the height of the van over here is 1.33 meters. So now I can write a sentence saying that the van that needs to be used to fit the pole and the folded up fabric shade, can just go around there in the space, needs to be 2.4 meters wide, 5.23 meters long, and 1.33 meters high. And that is a lot of working from a couple of paragraphs of information at the beginning there. The key to unlocking it is the work you do with the original diagrams, whether they're your diagrams, like I had to do for the van here, or whether they are diagrams that have been provided for you. Okay, a lot of that isn't needed to get achieved. That is taking you all the way through towards merit, and then your explanations and your discussions around the work that you've done would take it through to excellence. But hopefully that's helpful. Thanks, gang.